Good morning. In this video, we are going to discuss the second problem in friction, and I'm sure that at the end of this video, you would have learned many things or many important concepts in friction. In my last video, I discussed the basic concepts of friction through different cases. We analyzed it and we got very good understanding. I have given the link of that video in the description. Those who have not seen that video, kindly go through that one. Now let us go to the problem. Consider a block of weight W being kept on a inclined plane having coefficient of friction mu. Determine W, the weight of the block, and mu, the coefficient of friction. Give, there are two conditions. The first condition is the applied force is 10 Newton when the surface inclination is 15 degree. In the second condition, the applied force is 15 Newton when the surface inclination is 25 degree. So here is the diagram. So this is the block W which is being kept on a inclined plane having the angle alpha. Now the first condition is when this alpha is equal to 15 degree, the corresponding value of this P is equal to 10 Newton. In the second condition, when the alpha is equal to 25 degree, the corresponding value of P is 15 Newton. With this condition, they have asked to find the value of the weight of the block as well as the coefficient of friction. Now let us go to the second step, free body. So here is the free body diagram. First go to the axis system. Since it is an inclined surface, I have adjusted the coordinate system also. The x-axis is parallel to the inclined plane and y-axis just perpendicular to that one. And let us go and check the forces acting in this system. The weight, okay, as well as the applied force. These two are the active forces. Now this inclined surface will give you the normal reaction, that is nothing but n, and moreover there is a coefficient of friction on the surface, so there will be definitely the friction. And moreover, among these four forces, these three forces are either parallel to x-axis or parallel to y-axis. But if you take the weight which is neither parallel to x-axis nor parallel to y-axis, so it has to be resolved one along x direction and another one along y direction. Now you just take that this value is alpha, and the same inclination will be there here also with respect to y-axis. Now this is the x component having the value of w sine alpha, and this is the y component w cos alpha. When you have this x component and y component, make sure that these directions are taken in the correct order. Now in this third step is apply the appropriate equation. Since this is a static condition, I am going to use the static equilibrium equation. Moreover, here the given object is considered as a particle since there are no dimensions. So I am going to use the equilibrium equation of particle only. So there are two equilibrium equation. So this is the first equation, summation of all horizontal forces equal to 0, and this is the second equilibrium equation where the summation of all vertical forces is equal to 0. Okay, now let us go to the first one where the summation of all y component is equal to 0. If we go to this free body diagram, actually there are two vertical components. One is this normal reaction, another one is this w cos alpha, one of the component of the weight. And between these two, this is positive sign since this direction is it is going to positive side of the y, and here it is downward direction and the negative side of the y. So this is this is negative whereas this is positive. So this is what here also taken, n minus w cos alpha equal to 0, and now n equal to w cos alpha. Now the second equation is summation of all x component is 0, and if you go to this free body diagram again, there are three x components. One is P which is having positive sign, another one is friction having negative sign, and another one is one of the component of the weight W sin alpha which is also having negative sign. Now this equation of becomes like P minus F minus W sin alpha equal to 0. From this equation, P can be taken as F plus W sin alpha. This is the equation number 1. We know that friction can be written as mu into n, and in the place of n you just substitute this value w cos alpha. So this equation now will become like mu w cos alpha. Okay, now substitute this friction value in the first equation. So it becomes like P equal to mu w cos alpha plus w sin alpha. Let me take this one as equation number 2. Now apply the two conditions. First condition is when the alpha is 15 degree, the corresponding P value is 10 Newton. Now just substitute this one in this second equation. So it becomes like 10 equal to mu w cos 15 plus w sin 15. Okay, and now we just take w in the left hand side. So this equation now will become like a 10 by mu cos 15 plus sin 15, and take this as equation number 3. Similarly, just to substitute the second condition where P equal to 15 and the corresponding alpha is equal to 25 degree. Now the equation 2 becomes something like this. From this equation, take the W in the left hand side and you will get this as the equation, and take this as the equation number 4. Now just take 3 equal to 4, because in the equation 3 and 4 you see here in the left hand side you have W only. So you can take these two equations as something like this. So here is the equation now. Here you have 10, here you have 15, so you just cancel it by 5. Here you have 2, here you have 3. Now do the cross multiplication. Okay, that means 2 should be multiplied with this denominator and 3 should be multiplied with this denominator. Finally you will get the equation as something like this. Okay, now in this equation I am going to consider only the mu terms. Okay, so in this term you have the mu, and similarly here also you have the mu. Now the remaining two terms are marked by the into symbol. Okay, and just bring this in the left hand side and you just take this one in the right hand side. So finally the equation will be something like this. Okay, and you just take the mu outside. So this equation will be something like this. Similarly this equation now will become something like this. From this you can get the equation as something like this: mu equal to 2 sin 25 degree minus 3 sin 15 degree divided by 3 cos 15 degree minus 2 cos 25 degree. And here is the answer for mu, which is nothing but 0.0633, very low value, and substitute this mu value into the equation 3. So here is the equation 3 to get the value for W, and in the place of mu just substitute this value 0.0633. Okay, finally you will get the answer as 32.25 Newton. Okay, so finally just take and write the answers like this: the weight of the block is equal to 32.25 Newton and the corresponding coefficient of friction at the surface is 0.0633.